Hi guys, welcome back to my channel. I am again with you with the very basic and requested one topic, but interesting, and it is nomenclature of alkanes and alkenes. So first of all, what is nomenclature? A chemical nomenclature is a set of rules to generate systematic names for chemical compounds, and this is very interesting topic and easy if you learn the basic rules. So following those rules, you can name the hydrocarbons from simplest to complex ones, and you just need to memorize those rules into your memory and a little bit practice, and you would get command on it. So let's get started with the video, and first I will tell you the rules which you need to follow in alkanes and then for alkenes. So watch the full video to its end, and if you like the video, please give a big thumbs up, and if you have any problem, and then let me know in the comment section below, and do not forget to subscribe my channel. And if you want me to make a video on the topic of your choice, then let me know. So first of all, I will tell you about the alkanes. What are alkanes? And then we will start its nomenclature. So general definition of alkane is like acyclic saturated hydrocarbons are called alkanes. Acyclic means straight chain alkanes, not cyclic ones. And saturated means no unsaturation is present, which is double bond or triple bond. So I hope that you would know about saturation and unsaturation. So saturated ones are single sigma bonds, and single bonds, and double bond or triple bonds are unsaturated ones. So acyclic saturated hydrocarbons are called as alkanes. And alkenes are the simplest organic molecules which have only carbon and hydrogen atoms present in them, and their general formula is CnH2n plus 2, and they are commercially as important as fuels and oils are. So our topic is to discuss their nomenclature. So let's move towards the nomenclature. So there are two type of nomenclatures. One are the trivial names, and other one is the IUPAC name. Today we will discuss the IUPAC nomenclature for alkane and alkenes. And full form of nomenclature, IUPAC nomenclature is the International Union for the Pure and Applied Chemistry. International Union for Pure and Applied Chemistry. So there are 9 basic rules which you need to follow up during the nomenclature of alkanes, and in which first rule is that we need to locate or find out the largest continuous chain of the carbon atoms independent of the direction of the chain, whatever it is, whether it is horizontal or it is zigzag. And we just need to locate that where are the largest number of carbon atoms are present, in which chain largest number of carbon atoms are present. We will select that chain, and that chain will be called as main chain or stem chain or principal chain or parent chain. So I will describe you all of the rules which you need to follow up with the examples, with every rule with example. So first of all, I'm giving you the example in which 5 carbons are present in a chain and a substituent carbon is present. Just like this, valency of carbon is 4, so we need to attach 4 hydrogens with them, and another is 4 carbon atoms in a straight chain, and then as a substituent chain is also present. So first rule is locate or find the chain which has the largest number of carbon atoms. So if we see in the first example, we can see that this chain can be selected as, but this has 4 carbon atoms. But if we select this chain as parent chain, then it will have 5 carbon atoms. Then longest or parent chain will be this one. Let me encircle it for you. That is the longest chain with 5 carbon atoms. Longest or parent chain or principal chain, whatever name you wish to call it. So it is horizontal parent chain. As I told you already that regardless of the direction of chain, we need to select the chain. So in this example we can select that one, but that has 4 carbon atoms. But in the zigzag chain you will see that 6 carbon atoms will be included. This chain include 6 carbon atoms, and in straight chain there were 4 carbon atoms. So select that chain which has the longest or largest number of carbon atoms are present. So that will be the our parent chain. So for second rule, if there are two or more chains of equal lengths are present, both chains have equal lengths, means same number of carbon atoms are present in both of the chains, then the chain with the larger number of branches are present, that will be the selected as main chain. Then when I will give you the example, then you will see that how it applies. In first example, a chain with 5 carbon atoms is present and one as branch, just like this. Now see in both of the examples, in this chain has this chain has only one branch. As you can see, if we select this one, then one branch is present, and if we select this, then this is not the main branch, because this one has 3 branches. As you can see, 3 branches, this methyl, ethyl, a another methyl. So main branch will be that one, not the first one, straight one. Straight one will not be the main branch, but second one will be the branch in which 3 branches are present. So equal number of carbon atoms in both chains, straight chain and another one has equal number of carbon atoms, but we didn't select it because it does not have the branches. So now coming to the next rule, and the rule in which numbering of the chain is present. Now for numbering of the chain, we will number the chain starting from the nearest to the position, nearest to the substituent position. What does it mean? It means that we will number the chain in a way in which the substituents will get the nearest or closest number. When I will give you the example, then you will let know that how it will apply on it. For example, we have this chain, a molecule with 5 carbon atoms on the main stem. Now first of all, select the chain with largest number, and then this chain will be the selected, and 1 2 3 4 5 the numbering. Now you would see that on 2 positions substituents are present, which is 3 and 4. So numbering of the substituent is 3 and on 4 positions on the chain. Now in case of second one, if we number the chain in such a way that starting from another end, 1 2 3 4 and 5, now substituents will get substituents are present on 2 and 3 positions of carbon, as 2 and 3 positions. Now you will see that 2 and 3, we will select that, we will number the chain in such a way that substituents will get the nearest or closest number. So that one, 2 and 3 will be the correct numbering, and 3 and 4 will be the incorrect. Now for 4 rule, this is also the numbering rule, in which we will see that when 2 identical substituents are present, but they are at equal distance from either end, and then numbering of the chain will be like it will start with end which will give the substituents the minimum sum. For example, if I give you the example of, let me finish it writing for you, their minimum sum. It means that on different positions on the chain, same or identical substituents are present. For example, we have this 6 carbon atom chain, and on this carbon, and 3 identical substituents are present. Then if we number them starting from this end, then 1 2 3 4 5 and 6, and another numbering will be from another end, 1 2 3 4 5 6. Let's see, in first case substituents will get numbering 2 2 and no, this is the numbering of second one, but we just need to 2 3 and 5 is equal to 10 in first second case, and in first case 2 4 and 5 positions of carbon substituents, that will be the 11. To on position 2 4 and 5 substituents are present, and that sum will be the 11. But in second case substituent are on 2 3 and 5 positions, so their sum will be the 10, that is lesser than first one numbering. So second numbering will be the correct, which is giving us the minimum sum. So second numbering will be the correct. So for fifth rule, the position of substituent is indicated by the number of carbon atom to which it is attached. How we will tell that on which position the substituent is present? By the number of the carbon atom on which it is attached. The number is prefixed to the name of the group separated by a hyphen. So for example, we have a pentane with 5 carbon atoms just like this, and we have a substituent on second number of carbon. We will number the chain like 1 2 3 4 and 5. So on second position methyl group is present, and we will name it like 2 methyl pentane, because 5 carbon atom chain is, so it will be the pentane, 2 methyl pentane, and it will in methyl and 2 in between hyphen is present. So sixth rule is names of alkyl groups are written before the name of parent hydrocarbon in alphabetical order or in order of increasing size, and they will be separated by hyphen. So let me write this rule for you first, then I will give you the example that how it applies. We have a molecule with 5 carbon atom chain or pentane, in which two substituents are present. One is methyl and another one will be the ethyl on third position or third carbon atom, ethyl. So what is the rule? That is, name of the substituents or alkyl groups attached on the parent chain will be written before the name of parent hydrocarbon chain. So in alphabetical order, ethyl and methyl, E comes first. So 3 ethyl, 2 methyl pentane. Then parent chain will be the written name of the parent chain. First name the alkyls or substituents and separated by hyphen in alphabetical order, 3 ethyl, 2 methyl pentane. So the seventh rule, which is that if two or more identical or same substituents are present, when two or more like groups or identical groups or same substituents are attached on the parent chain, then their names are indicated by prefixes, which are di, tri, tetra, etc. And di is for 2, tri is for 3, tetra is for 4, and their numbers are grouped together and are separated by commas. You will see in this example we have a chain containing 6 carbon atoms. Main chain will contain 6 carbon atoms and 1 ethyl and 3 methyl substituents are present on it. This methyl and on, for example, 1 methyl is present on this position. Now numbering will be start giving them minimum sum. That will be the parent chain, numbering from here 1 2 3 4 and 5. So they are getting 3 2 3 5 positions. So first of all we will write the name of ethyl. E comes first, alphabetical order. So 3 ethyl and 3 methyl are substituents are present. 1 ethyl substituent is present and 3 methyl. But 3 methyl is, then we will use prefix tri. And so first write the 3 methyl position of methyl is on it is present on 3 third carbon atom. So 3 ethyl, 2, 3 and 5 trimethyl. Di for 2, as I told you, tri for 3 and tetra for 4. So 2, 3, 5 trimethyl, and the parent chain is containing 6 carbon atoms, then it will be hexane. So 3 ethyl, 2, 3, 5 trimethyl hexane. So eighth rule is, if two identical groups appear at the same carbon atom, but they are not on the separated carbon atoms but on the same carbon atom, then the number is separated twice and separated by commas. It means that we will write that number of the carbon two times but separated by its commas. For example, we have example of this carbon atom this carbon chain containing 5 carbon atoms, and 2 methyl groups are present on the 2 position, 2 carbon atom. So 2 methyl substituents are present on this chain, then we will write 2:2 dimethyl pentane. Both of the substituents or both of the methyl groups will be named 2:2 dimethyl pentane. So for the ninth and last one rule, the longest chain of the substituent is numbered starting with the carbon attached directly to the main chain. Then parentheses are used to separate the numbering of the substituent and the main chain. But the longest chain of substituent is numbered starting with the carbon that is directly attached to the main chain. I give you, it means that if a main chain has a sub chain, then how we will write its name. For example, I will give you the biggest or longest chain with 10 carbon atoms, and we call 10 as decane. We have a 10 carbon atom chain, but that chain will also have a propyl chain. You cannot say the subchain as propane because one hydrogen atom will be less, so that will be the propyl. So this is main chain, 10 carbon atoms, a methyl substituent, and another substituent, that is propyl subchain, you can say it just like this. Propane, 3 carbon atoms on subchain, so this is, and then now longest chain is containing 10 carbon atoms. On 3 position a substituent present, and on 5 position a subchain is present. So these are named as 1, 2, 3. These are numbered as 1, 2, 3. This is ethyl C2H5. So how we will write its name? We have a 3 ethyl, another one is propyl, so we will write it later on. First we will write 3 ethyl, and on 5 position we have a propyl, and propyl have 1 methyl on 1 position. So 5 on 5 position 1 methyl, and whole of the substituent is propyl. So 1 methyl propyl decane. It's very simple. On 5 position 3 position ethyl, and on 5 position a propyl is present, but on propyl on 1 position it is methyl. So 3 ethyl 5 1 methyl propyl decane. So that is all for the nomenclature of alkanes. Now coming to the nomenclature of alkenes, let me first introduce alkenes to you, then we will start its nomenclature. So alkenes are acyclic unsaturated hydrocarbons. Alkanes were saturated hydrocarbons with no unsaturation, but these are unsaturated hydrocarbons containing the double bonds are called as alkene. So acyclic unsaturated hydrocarbons are called as alkenes. Let's get started with its nomenclature. If you have learned the nomenclature of alkane, then it will be easier for you because most of the rules are same as just like as alkanes. So first rule is in them double bond is present, so that will be the difference only. So for its nomenclature 7 rules will be followed, and in which first rule is just like alkanes nomenclature, that is, first of all, locate or find the longest continuous chain containing a double bond. that longest chain which contains double bond as a parent chain will be selected. In alkanes there was not any double or triple bond, so we didn't mention it over there. So in alkenes that chain will be selected which will have double bond. So for second rule of it, the ending of alkane ane is replaced by ene, ene. So for alkenes it will be, for alkanes it is anes ending, and for alkenes it is ene. So for example, first chain we have this one in which a 3 carbon atom chain is present and double bond is present. So we will select that chain which will have double bond, so that chain will be the selected. And another example, if we have branch just like this, then this will not be selected as parent chain because it does not contain double bond, so that is incorrect and first one is correct. Select that chain which have double bond. So third rule is the chain is numbered in such a manner that as to give the minimum number to the double bond. It means that we will start numbering from the chain which will give the double bond the minimum number. For example, if we start the numbering from this 1 2 3, the double bond will get one position. But if we start numbering from this carbon atom, then it will get 2 number, it will be incorrect. So this is third rule, that number the chain in such a way that double bond gets the lowest number. Now fourth rule is how to give the number to the double bond. Then the number position of the double bond is indicated by the lower number of carbon atom. For example, when I will write the example, then you will let know. Lower number of carbon atom will be indicate the position of the double bond. For example, we have a chain like this containing 4 carbon atoms, and if we number the chain in such a way, let me finish. 1 2 3 and 4. Now this is 1 ene. We are giving the double bond lowest number 1 ene. And in second case, if we write it 2 ene, then it will be the incorrect. We will give the double bond as 1 ene. That double bond is present on 1 ene, not on 2 ene. So fifth rule is the lower number of the carbon atom is placed before the name of parent alkane. It means that while writing the name of parent alkane, let me write this rule for you. While writing the name of the whole chain, first the lower number of carbon atom on which double bond is present, and then the parent name will be written. So sixth rule is alkyl groups on the chain are indicated by the method mentioned just like in alkanes. Like they are separated by hyphen and they are written in alphabetical order. For example, if I give you the example of a molecule which has 4 carbon atoms, in which CH3, CH has a methyl group on it, then C and a ethyl group is present and a double bond. So number the chain 1 2 3 and 4. Now it has 2 ethyl on 2 carbon atom, ethyl is present, 2 ethyl, 3 methyl, 1 butene. Fifth rule, you see it is following on. So for seventh rule and last rule for the alkenes nomenclature is presence of more than one double bonds. If more than one double bonds are present, then it is indicated by the suffix diene for 2 double bonds, triene for 3 double bonds, and so on. Tetraene for 4 double bonds, and pentaene for 5 double bonds. And let me give you the example of a butene. First let me finish with writing it. So we have a butene, CH2 double bond CH, and a CH and double bond CH2. So number the chain, whatever you number, it will be the equal. same numbering will be from the both side. So it will be the named as buta 1 and 3, 1 and 3 diene buta, or it can be written as 1 3, indicate the position of double bond on one position and three position. 1 3 4 carbon atom chain it is, so butadiene, 1 3 butadiene, it will be written as just like this. If I give you the another example for practice, in which we will have a methyl group on 2 carbon atom. Number the chain first of all, 1 2 3 and 4. Then write the name of substituent methyl first, 2 methyl, 1 3 positions of double bonds, butadiene, just like first example. So that is all for the nomenclature of alkane and alkenes. Hope you all got it, and if you have any problem regarding to its this video, then please let me know in the comment section, and do not forget to subscribe my channel. And if you want me to make a video on the topic of your choice, then let me know, I will make video on that. Thank you.